Hello, everyone, and welcome to Intel on AI. I'm Ryan Carson, and I'm joined by my co-host Tony Monkolsmy. How's it going, Tony?
Hey, it's going well, Ryan. Good to see you, man.
Good to have you here on the show. So I'm really excited today because we have an amazing guest, someone that knows a lot about AI and has some amazing world experience doing real things with AI. I'm excited to welcome our guest today, Rao Desineni. Welcome to the show. How you doing?
I'm doing great. Thanks for having me, Ryan.
Yeah, it's good to have you in the show. So, Rao is a senior director of data analytics and factory automation in the Foundry Technology Development Organization at Intel, based in Hillsboro, Oregon. He leads a team of data scientists and software engineers responsible for developing and deploying at scale semiconductor manufacturing analytics solutions. With broad expertise in semiconductor technology development, design enablement, design automation, manufacturing and test, Rao is passionate about bringing applied intelligence, not just artificial intelligence, applied intelligence solutions deployed at scale into all aspects of semiconductor design and manufacturing. Previously, he spent 6 years each at Global Foundries and IBM. Rao received his PhD in ECE from Carnegie Mellon University. No joke, that's pretty hard to do. And has published over 30 conference and journal papers and holds 8 US patents. That's 8 more than me, all on semiconductor manufacturing and test. Rao, it is wonderful to have you on the show. So let's get right into it. You have done some really interesting things. Rubber meets the road where AI actually gets installed and deployed into businesses. And I would just love to hear a story where you saw that happen and how it works in the real world.
Ryan and Tony, first of all, thank you again for having me on the show. I would say, as a person who's been in the semiconductor industry for 20 years now, I graduated in 2006, so that'll about 18 years there and 6 years in the industry, in the academia, but 24 years really, or more than 2 decades. This is the most exciting time to be in semiconductor industry. Very simply put, it's I think one of the best kept secrets that the industry that is responsible for this AI boom that we see all around us in terms of all the data that we are caching and storing these days. Any kid knows once they watch a YouTube video, the follow-on video is something related to what they just watched, not only kids, even the parents, right? And
Yep.
how does it happen? That's a form of AI. But the whole industry that has evolved, that has been responsible for evolving this AI is actually semiconductors, because we are the ones that make the chips. The second best kept secret in semiconductor industry is we generate some of the biggest amount of data. You'd be surprised and shocked at the amount of data that we deal with here at Intel. It's upwards of hundreds of petabytes. And a lot of people think social media companies, they do generate a lot of data, but we are equally adept at generating the data. So once there's data, the data needs to be converted to information. And that's where we used to do quite a lot of math. In 1980s, it was called statistics. In 1990s, it was called advanced statistics. And in 2000s, we started saying, I'm doing more advanced statistics. And these days, they say it's machine learning and it's AI. If you look at it, it's all the same group of techniques. AI subsumes machine learning, it subsumes advanced statistics sometimes, some operations research. This is all different techniques of AI. So yes, I have plenty of examples how we take this tremendous amount of data generated in manufacturing facilities, which are codenamed fabs, like the one to my east side here in Hillsboro, Oregon. That is one of the world's most advanced fab in the Foundry Technology Development Organization of Intel. It's almost always called the crown jewels of Intel. I'm very proud to be working and building automation solutions, data solutions, and AI solutions for this fab. One example, I think that's quite relatable to everybody is we work at nanometer scale dimensions. That's a dimensions of transistors and wires that we print on this tiny chips that we make on top of the wafers. During the manufacturing process, some defects are introduced, unknown, unwanted manifestations of the silicon manufacturing process. So in the very old days, 70s and 80s, there used to be humans who would literally take the wafers after every few process steps and look them under the microscope to see if those nanometer level defects are there present. And then over a period of time, we got tools, equipment that would automatically look at those wafers and they do inspection, literally like a camera, and then those camera images are then processed using another equipment, and then we get tens of thousands of these little mosquito bites on top of the wafer. Then the task of the engineers or technicians is to find which one of them are real defects and what are the types of defects. So once you know what the type of defect is, then you can find what the source of the defect is, so you can fix it. Like in 90s, early 2000s, methods started coming called automated defect classification. So as early as late 2009s, 10s, a lot of industry equipment started producing this AI-based technique called automated defect classification. We in Intel actually out-innovated quite a lot because we regularly benchmark in terms of accuracy, performance, and we use this AI technique, including the much famed generative AI that is all the buzz these days. We've been using those techniques in our fab to automatically classify the defects that are coming out of our process steps, and then find the root cause of them with very high accuracy, accuracy upwards of 90%, which is like when we benchmark the computer solutions, we outbeat them.
And Rao, when you talk about kind of the benefits of using AI and computer vision, can you quantify how is that different from what we did in the past? You mentioned over time we had statistics, different types of optimizations, ways of doing it. But now using computer vision AI, is it 10% better? Is it 50% better? Is it exponentially better using AI? What's the delta there?
So, Tony, great question. First of all, what everybody needs to understand is the complexity of the semiconductor manufacturing process has grown exponentially. I mean, it's the one way to easily relate is when Apollo 13 was launched, the size of a computer was the size of about 10 rooms, right? If you must have watched the movie, Tom Hanks movie, right? Apollo 13, the IBM 360 mainframes were there. So now more power than that computer is on this cell phone. So it's become miniature, right? It's become miniaturized. When you become smaller and smaller dimensions, the type of defects that happen are getting more and more difficult to see. So see, when I say see, it could be human eyes, could be microscopes, could be telescopes, not telescopes, microscopes. So it's become difficult, and the complexity of the manufacturing process that prints these small structures on the chips is increasing. So nowadays, to find the defects on the chip, the old techniques would simply not work, Tony. You have to have higher precision cameras that capture the number of images and the nanometer level pixels that we have to identify as good versus bad is incredibly hard. So current techniques completely depend upon computer vision algorithms or neural nets. These are all classes of AI techniques that we use to detect these defects in the first place.
Wow.
To detect, and then once you have detected, classify them. That's very important.
So there's probably a lot of people listening that know they need to use AI. They're excited about it, especially in their business to improve their processes, reduce their costs, just like you're saying that we do at Intel to detect errors. How do people think about starting that process, right? So, I mean, you eventually got to the point where you had this hardware that was actually doing detection and then, analyzing the data, but help folks understand, like, how do they even start this process of thinking about deploying AI into their business to solve a problem like that?
Yeah. I've been in the industry, like I stated earlier, for about 2 decades. One thing that is a common trend is whenever there's a cool new technology, everybody runs towards it. There was the year 2000 when I just came to the US for the first time. The Y2K problem was going on. Everybody wanted to learn Java. right? And then in between came the cryptocurrency, it came blockchain. Everybody wanted to learn that. There was a time when people were learning Oracle and DBA admins, everybody wanted to become. Off late, the craze is machine learning and AI. Everybody wants to learn. But one advice that I have for everybody is if you are educated, if you have a background in physics, solid state physics, or electrical engineering, you cannot become a data scientist overnight. You have had training for what, 10, 15, 20, 25 years of academic school, followed by experience, work experience. So what you bring is a very important portion of AI called domain expertise. So never forget, in the run to become an AI expert, it's not it's not necessary. Neither is it required that you go take Coursera courses, write a lot of Python, take machine learning courses from Andrew Ng, and suddenly become a data scientist. You may become a coder, but you may not become a fixture just because you never had the years of training that a proper computer science graduate had. It's not to deter you. It's not to say that you should not take up data science, but just bear in mind that you cannot become an expert in a month or a year, right? It requires. Having said that, that was just my cautionary tale that I use for every new person who wants to suddenly become a data scientist because the AI boom is going on. That was just that preaching, sorry. But one very important point, Tony, to understand is AI is zero zilch useless if not supplemented with a good domain expert who knows where the problem is, what is the problem to solve. An example that I used with my kids recently, I have 14-year-old kids, so I used with them, I have twins, so that's why I use a plural sense. I use with them is if you want to design a robot that opens a potato chip bag, you must first teach it that this is how you hold the bag and you open it. So you are the domain expert of opening a chips bag. If you are not there, the robot won't know how to start. You have to train it, right? So domain expert is always needed. That they have to explain, this is the problem I'm trying to solve. So they become part of the AI solution provider, actually. That's actually a very big part. 10% of every AI solution building is the domain expertise, at least 10 minimum. Then you need to employ some people who understand data, how to take the data, how to store it. Then you need to employ people who do modeling, how to take that data that pulled from the data storage, create a model. And then you need software engineers who take that model, apply, and then give maybe a user interface, maybe a web page that people can go and click. So it takes a village. So Tony, no short answer. It takes a team of different type of experts coming together to build AI solutions.
Awesome. Thanks for sharing that. It's good to see how you don't have to stress about immediately becoming the expert data scientist. You can rely on the fact that you have real experience that you can apply to the problem set. The only thing I'll disagree with you on is I don't want my kids to know how to open more chip bags. I don't think they need, and I don't want them teaching the AI that. So
let's call them how to cut an apple, right?
Do some exercise away from their screen.
Yes.
Go ahead,
So-
Tony.
Yeah, Rao, when you look at the problem as a domain expert, like let's say I'm a business, and you've had lots of experience, again, applying AI. If I'm a business, how do I know when I should start thinking about using AI? Like, how do I know, do I have the right data? Because, if I'm a small business, I may not have a lot of data. So how do I know what's the right use case to start looking at whether or not I can apply an AI solution to my problem?
Absolutely. I think these days, with the advances that we have made as a society in terms of ability to store data, it's how cheap the computing has become, right? If you start finding yourself doing a task repetitively, every business have some sort of a call center, right? I mean, you sell a product, you sell a services, somebody's calling you, hey, X went bad or Y became bad, your product is out of warranty, how do you support? Even if you're vacuum cleaner builder, you go and do furnace repairs, you work in semiconductor fab, right? Always there is something called customer support. What happens in a typical customer support? issue happens and somebody picks up the phone and they look up a manual saying, this is okay, this broke, this is how you have to do, all else works, then I'll send you a technician, right? But the first line of defense is a repetitive task. If you find yourself looking at something that's a repetitive task, then that can be automated. How can it be automated these days? Everybody, I think, you would have to be hiding under a rock if you haven't heard of ChatGPT, right? Right. So there is large language model based generative AI. There is a lot of usages of that in our line of work too, because we deal with hundreds and thousands of millions of records of what we call knowledge articles. And equipment in the fab went down. It has to be brought back up. It takes me an average of at least 1 year of training a human being to become experienced enough to debug why the equipment went down. These equipment are like $100 million tools, right?
Wow.
They're complex. How to even open the nut or a screw requires training. Now, if I can take all those knowledge articles and encode them into a large language model, and instead of somebody learning by rote, if let's say, Tony, you are new to the company and you have been asked, Rao says, hey, the equipment is gone down, debug it. Where do you start? You read the manuals, or isn't it easy if I have a chatbot? I ask the question, how to open this nut? What do I do now? When this equipment went down because of this signal 2 years back, what did the engineers do to bring it back up? You ask those questions and your chatbot gives you a response back. That's the power of generative AI with large language models that is available at your fingertips now. So short answer, find yourself doing what used to be mundane tasks, repetitive tasks. I wish there was another experienced person standing next to me who has done it before. I wish Joe was here that could have solved this. If you find asking those questions, you want an AI in your hand.
Love it. That's a great answer. And actually, the process of going through documenting that repeated process is actually good for the business anyway. And that's something you could train on. So let's go back to story time. So I'd love for you to reach back in your memory and recall a story where you saw AI deployed in a real world business scenario, and what went right, what went wrong, and what did you learn?
Yeah, so I'll give you one contrasting example first, and maybe two good examples. One which is working at scale volume here at Intel, and one that we are right now building. So as a long-time people manager, I have done a lot of hiring. When I get resumes these days, I get lots and lots of resumes and supplier companies that are coming and talking to us about new AI solutions. We look at them, I read the resumes, then I ask them, what is the scale of your solution? How many users are there? How big the system is? And I'm quite disappointed, generally speaking, that they basically show me this little white paper or a research paper that they published. I'm like, how do you put it at scale? When you introduced me, Ryan, you used the word applied science. I use the word a lot because applied science to me is AI deployed at scale. Artificial intelligence deployed at scale. That's what I call, sorry, not applied science, applied intelligence. Applied intelligence is, to me, AI deployed at scale. That means it's the Netflix, it's a YouTube, it's my automated defect classification that hundreds of users can use. It's saving me X number of dollars. It's running autonomously. It just works. There's no bugs. Very rarely there are bugs. That's at scale. So that was my negative. Now on the application side, there's another very cool application which is we call autonomous machine learning. So Intel makes a lot of chips, a lot. We are one of the biggest volume provider, including many on the laptops that we have everywhere, right? Hundreds of millions of chips. So chip manufacturing is very interesting. As you can tell, I'm very passionate about our industry, semiconductor. I love being in this industry. So I'll keep quoting these examples. So chip manufacturing is a very complex process, but also from one step of manufacturing to next step, if a defect goes undetected, if there's a test escape, at when we first make the chips, they're on the form of a wafer. After the wafer manufacturing is completed, we cut them up, make individual dies or chips, and then package them up. Sometimes we put 2, 3, 5 different types of chips on the same package. Now imagine I got 5 different wafers, 5 different type of products that I have to assemble together in one package, right? Now assume that the 4 products are really, really good, solid. They're like high quality. But the 5th guy comes in, which is not so good quality product. I stick them. I go through a manufacturing process in which I assemble these 5 dies, these 5 chips into one package. Because of this one bad fish, I have to throw away the entire package. Doesn't
Oh,
make common sense, right? What you've done is you've thrown away 4 perfectly good dies that if they were paired with the 5th nice guy, it would have made me revenue. But now
Yes.
I'm not only losing revenue, but I have a collateral damage, right?
Yep.
So this is the process. This is why we say after every manufacturing step, if you go to the next step and you detect the problem there, the cost of detection is 10x higher. Okay, so remember, just chips are made on wafers. Wafers get diced up or cut. Then we get individual chips, and those chips are assembled together to make a package. Then the package is tested for reliability, and then package is sent to the customer. At every step, if the customer finds the issue, it's almost a million X worse than if I could have found the defect at wafer manufacturing. Just remember this rule of thumb. What the AI technique that we have running is we proactively look for the signature. Remember, I told you collect terabytes of data every day. What happens is that at every step that I explained, we're collecting lots of data. From the data, we create a thumbnail or a signature. The signature is using the future data, using the data from the downstream steps. We can predict using this thumbnail will result in this chip being the root cause for that package being thrown away later.
Oh, wow.
So I can create a prediction model, right? This is
That's
called
cool.
predictive die kill. So then by the end of this process step, I can predict that this guy with a 99% or 95% certainty is going to be a bad fish. Let me block him right here. It's a risk
Right.
I'm taking. There's a 5%, 10% probability this guy is good. But my odds are this guy is going to corrupt my collateral damage later. So this technique is called predictive die kill. And the beauty is for hundreds of millions of dies or chips that we make every single day, this machine learning process is running at scale, autonomously detecting, okay, this guy is a weakling. Let me stop him right now. Not, but
Cut
on
him
the other
early.
hand, sometimes when we have supply demand scenarios in which ship me every part you can make, then I may be okay to take a risk within the guidelines of Intel quality reliability specs. So this autonomous machine learning process runs 24/7, in which we are constantly looking at the data signatures, predicting what will happen to this chip in the future, and either screening it out, that means removing it from supply chain right now, or continuing it on.
Wow. That is
I think it's a little
fascinating.
complicated subject. I hope I explained it that you can understand.
Well, I've never made a chip, and I think it's fascinating that you can predict from what's going to happen in the future based off of what you learned in the past. And there's so many business use cases for that. I'm thinking
Exactly.
back to previous businesses I had where you're trying to predict churn of customers or behavior of customers, and you could train on previous
Yep.
data. So that is fascinating. Thank you for sharing.
Yeah, and I think it takes a lot of pieces to make this happen.
In terms of
And I think yeah,
yes,
I was gonna say
a lot.
so like what are those pieces that you're using internally that Intel has homegrown, or using stuff that's open source? As somebody who has to put together these solutions, what's a good way to do this? Is it build your own, which seems crazy? There's so many things out there. Are you using a lot of open source stuff? Are you using a lot of Intel stuff? What's that process look like when you're trying to build these kind of applied pipelines?
Yeah, so the domain expertise is all internal. The data that we collect and how we store it is all internal. Where the open source stuff comes in, like Tony mentioned, is open source machine learning models. We use sometimes we use open source machine learning models, but oftentimes we actually build our own models, ML libraries, from scratch using first principle math and low level programming languages like C, C++, because they're optimized for Intel architecture. Intel architecture means Intel Xeons, Intel Gaudi servers, accelerators. We tend to use a lot of Intel hardware, so we optimize our own libraries for our Intel architecture, and we have a massive on-prem private cloud infrastructure in which we use to train these models on GPUs and on AI accelerators, and then we use them for also to inferencing. So that's how we build at-scale solutions, Tony. But open source models sometimes work well, but remember, a lot of open source community that builds the models is for applications that are not meant for semiconductor manufacturing. They might be meant for classifying, I mean, pardon me for saying, cats versus dogs. I'm not trying to trivialize it, but a lot
Important.
of social media is what is driving a lot of open source libraries. Financial engines are driving it, but
Right.
our data is extremely noisy, very biased. Biased means there's a 99.999% good, very very small portion is bad, so that becomes a very biased data. So we have to build some custom libraries. We use that also, and then we build software using some of the open source libraries from Java. Maybe sometimes we write applications, software languages using Angular, which are public domain art languages, but overall a mix.
Wow.
Okay.
Rao, thanks for diving deep on these solutions, and it's fascinating to see how we solve some of our own problems here at Intel with AI, but combining deep domain expertise. And I appreciate you drawing out some of those lessons for the listeners. We're going to wind it down, but before we do, I would love for you to share where people can find out more about what you're excited about or what you're interested in online, or where they can get in touch with you. Where should they go?
Yes. Before we leave, I would like to draw attention to one more very exciting area or a new trend: generative AI with large language models. We are very excited about it. Ryan, I would be amiss if I did not state that Intel's heavily investing in it. Just last week, there was an Intel Vision event in which our CEO Pat Gelsinger did a keynote, a fantastic keynote in which we featured some of our work of using generative AI with large language model in our fab. So it's a trend, very important trend. You see very soon co-pilots that are helping people write emails, digest emails, write meeting minutes. There are coding assistants that help people write C, C Sharp, Python, Perl, Java type code. And what is the one thing that every coder hates? Documentation, right? It helps you document it. It helps you do unit testing. So we are adopting all of those. Some of the solutions we are building internally, some we are buying off the shelf and reusing them. So I would say if you hook up with me on LinkedIn. If you look at, just start following hashtag I am Intel. There's a lot of press on LinkedIn and or YouTube that you can watch our AI videos. This AI podcast is a great medium also in which we publish. Also, there are several white papers that Intel AI team keeps publishing. So if you just Google or search in LinkedIn or YouTube, you should find quite a lot of resources.
Perfect. Well,
Yeah,
thank you
and
so
we'll
much for your
include
time,
those
Rao. I know
links
you're
too.
very busy. Thanks, Tony, as
Okay,
well for
thank you.
joining. Hopefully, we're all going to go on and use some AI probably to make our lives easier and faster. Thanks to that, all the hard work you do actually at the fab to make it happen. So thanks, everybody, and we'll
Thank you
catch you
very
next
much.
time.
Thanks, Ryan, Tony, for having me.
Thanks, Ralph. Bye,
Bye.
everyone.